Welcome to Cognitive Psychology. You might have completed the course of Introduction to Psychology and heard of cognitive psychology. As the name suggests, cognitive psychology is the study of cognition, and cognition is defined in the dictionary as to become acquainted with or to know something. It is the study of how people acquire, store, transform, use, and communicate information. It is the study of mental processes that affect behaviors, including perception, attention, memory, decision-making, language, and so on. The course objective is to introduce the contemporary thinking, methods, and findings in major areas of cognitive psychology that include perception, attention, memory, reasoning, decision-making, and so on. To know how these ideas develop, it is also essential to learn the history and philosophical genesis of major approaches such as representationalism and realism. Throughout the course, we also introduce experimental methods, tools, and technologies that are used to test and solve specific questions. We hope at the end of the course, you are able to pose good research questions and plan out logical experiments to test the hypothesis. Next, let me walk you through a brief history of modern cognitive psychology. Psychology as a formal discipline has only been around for a little over a century. Historians often date the founding of the field of psychology back to 1879, when Wundt founded the first laboratory of experimental psychology at the University of Leipzig. Wundt and his student Titchener used the method of introspection to study cognition, or thinking process. This method requires individuals to pay careful attention to one's own mental activity and describe the thinking process. Obviously, we all can see that this method has limitations, such as one is not always aware of how he or she thinks, or can put the thinking process in precise words. Functionalism advocates that the basic aim of psychology is understanding the function of the mind, the ways in which mental functions let individuals adapt to their environment. Proponent of pragmatism and functionalism William James introduced experimental psychology to American academics. His textbook, The Principles of Psychology, published first in 1890, is still highly regarded and widely cited today. The school of Gestalt psychology holds as its central assumption that psychological phenomena cannot be reduced to simple elements, but must be analyzed and studied in their entirety. Gestalt psychologists believe that observers do not construct a coherent perception from simple, elementary sensory aspects of an experience, but instead apprehend the total structure of an experience as a whole. Behaviorism was a movement originated from the United States, and two leading men were John Watson and B.F. Skinner. Behaviorism was active and dominant between the 1930s and 1960s. Behaviorist psychologists emphasized the importance of measurable data. They think that the mental processes were not directly observable and therefore cannot be studied. Psychologists should only study the observable and measurable behaviors. In the 1970s, the cognitive revolution happened, where scholars such as Noam Chomsky raised that both measurable data and mental processes are important. Although mental processes are not directly measurable, they can be inferred based on observational behavioral outputs. Furthermore, with developments in neuroscience, the study of the brain-based underpinnings of psychological and behavioral functions become possible nowadays. Next, let's revise some commonly used methods in contemporary studies of cognition. The premise is that theories and data develop hand in hand. Data can only be fully explained with theories, and theories are insufficient without data, thus creating the cycle of science. The popular methods include experimentation, case study, psychological studies, naturalistic observation, self-report, computer simulation, etc. Among these, experimentation is a trademark of cognitive psychology research, and it is one of the greatest contributions of cognitive psychology to social sciences. Typically, in cognitive experiments, we study X effect on Y for some population P. X is called independent variable. Y is called dependent variable. P is represented by a sample. We test a sample to infer about the population. For example, to study the effect of course load on alcohol consumption among university students. In cognitive psychology, we manipulate the independent variables and test how behaviors change as a result. The typical independent variables include types of stimuli. For example, we can be testing words versus non-words, face versus non-face, a lot of work versus a little bit of work. Different samples. For example, we can contrast healthy individuals with patients, males with females, samples collected on day 1 versus samples collected on day 2. Physical conditions. For example, viewing in darkness versus viewing in daylight, holding warm water versus holding cold water, a quick flash of display versus prolonged viewing. Feedback, which includes veridical feedback or distorted feedback, or feedback or without feedback. Note that there is a difference between an independent variable and levels of a variable. For example, participants' grade is one variable that has, say, 4 levels, 1st, 2nd, 3rd, and 4th grade. The typical dependent measures are behaviors in response to the experimental manipulation. It is what we measure. By contrasting behaviors with and without the experimental manipulation, we can get the causal relationship between the independent and the dependent variables, or the experimental manipulation and the behavioral change. Typical dependent variables in cognitive experiments include response time or reaction time, accuracy, which means % correct, error rate, which means % incorrect, and signal detection. Also, precision of performance, which is measured in variance, and general behavioral performance, for example, the amount of weights lifted or the distance run. Next, let's look at a toy example and consider how a cognitive psychology experiment is done. Let's say we want to test the effect of course load on alcohol consumption among college students. From the question, of course, we must consider the amount of work as an independent variable. But this effect might be different among students of different years and sexes, so we can also consider the year of study and the sex as modulating factors. When we conduct experiments, one of the first things that we must do is to select a sample. The sample should be representative of the population, and depending on how many independent variables and the levels of each independent variable, the sample size would differ. Determining the sample size and selecting a representative sample are what you learn in the course of statistics. Also, when we set the independent variables, we need to consider how many levels within the independent variable and also the experimental and control groups. As you have learned previously, to test the effect of a treatment, we need to recruit 2 groups, one going through the treatment and one not going through the treatment, or the experimental and control groups. Finally, we need to check the correlations between the independent variables. In principle, the independent variables should not correlate with one another, but in practice, they often are related. For example, in our toy example, the amount of homework may be correlated with the year of study. Correlations among independent variables cause the problem of multicollinearity. In our toy example, the dependent variable is straightforward, the amount of alcohol consumed. Nonetheless, there are 2 ways to collect this data: asking participants to report or taking regular blood tests. You may think that taking blood tests is a more objective way to obtain data, which is true, but self-report is a more feasible and efficient way. When you are designing experiments, you need to balance between the 2. When measuring dependent variables, one needs to consider the measuring scales and whether the data is nominal, ordinal, ratio, or scale determines the statistical tests that you apply to the data. The collected data often contains measurement errors. A measurement error is the difference between an observed value and the true value of something. There are 2 main types of measurement errors: A random error is a chance difference between the observed and true values of something. For example, a researcher misread a number on the ruler and wrote down an incorrect measurement. A systematic error is a consistent and proportional difference between the observed and true values of something. For example, a miscalibrated scale consistently registers weights as higher than they actually are. Systematic errors are generally a bigger problem than random errors because they can skew your data to lead you to attribute the systematic errors to the effect of an independent variable and thus make wrong conclusions. There may be an untested effect that accidentally affects performance in the experiment. For example, in our toy study, weather is not an effect being tested, but it may affect alcohol consumption. This is known as a confounding variable, which is an unmeasured third variable that influences the relationship between the independent and the dependent variables. When we design and conduct experiments, we need to consider and control such effects a priori. Other study methods include case study, which entails in-depth exploration of a small number of individuals. This is especially common when studying patients with lesions or diseases that affect part of the brain and lead to changing of behavioral patterns. Case study is observing special cases, and it is sometimes combined with naturalistic observation, which means observing behaviors in their usual settings. Finally, an extremely popular method nowadays is computer simulation. Computer simulation is highly relevant in studying cognition because at the theoretical level, the brain may function by doing rule-based simple manipulations just like a computer. Furthermore, at the practical value, computer simulations allow researchers to acquire large amount of data in a reasonable period of time. This kind of large model and big data are increasingly useful in understanding the human cognition. To sum up, in this class, we introduced the definition of cognitive psychology, a brief history of how researchers have attempted to understand and study human cognition, and the commonly used empirical methods. And along the way, we revised concepts that you have learned from related courses, such as Introduction to Psychology, Statistics, and Experimental Psychology. We shall continue using this web of knowledge to solve more particular problems in later lectures.